I built a deep Q network to teach a reinforcement learning agent how to play Space Invaders. Here's what that means. There's really three key elements that we need to figure out. How reinforcement learning works, how Q learning works, and how deep reinforcement learning works. Reinforcement learning is basically when an agent interacts with its environment. The agent takes different actions, and from those actions, the environment returns a reward. Now that reward can be either positive or negative. And once it gets a reward, the agent transitions to a different state. Now that state for the agent is just where different things are accessible. Now, in the context of Space Invaders, the agent is the little green spaceship. And once the agent is able to do an action, the environment gives it back a reward. Now an action would be something like moving left, moving right, shooting, or even staying still. And a reward would be something like incrementing its score for a positive reward, or making it lose a life for a negative reward. And the agent's state is basically whatever is immediately accessible from its current position. So now that we covered the reinforcement learning basics, let's move on to Q learning. Q learning helps us figure out a policy, which is just a way of doing things. It helps us learn what actions to do given certain states to maximize long-term reward. A general strategy in Q learning is to explore a lot of different possibilities at the start of the game, and then as we progress and learn what the optimal combinations from states to actions are, we exploit certain strategies in order to give us the most score possible, because we actually know what to do now. This is known as the exploration versus exploitation trade-off. Now once we figured out the maximum reward for doing a certain action given a certain state, we figured out what action leads to the most positive long-term reward. And those maximum possible rewards are known as Q values. Those Q values are then stored in a Q table. And this Q table serves as a lookup table, where we can find the best actions to take from a certain state that will give us maximum possible reward in the future. And eventually, once we have enough entries in our Q table, we'll know the best possible action given any single state. So we always know what the best action is and what the best thing to do in any given situation is. So with Q learning, we figured out what the best actions were. But how do we even figure out what the state for the agent is? This is where deep neural networks come in, specifically convolutional neural networks. Convolutional neural networks basically allow the network to see what's going on in a game. If the agent were like a human playing a video game, then the CNN would be like its eyes. When dealing with deep Q networks, normal CNNs usually have a pooling layer that discards spatial information. But it's important to have spatial information in a deep Q network so we know where everything is and what it is. And if the convolutional layers are like the eyes of our network, then the fully connected layer are like our brains. They figure out what the best action to take is given the certain state that our eyes have seen, and they output an action that we should take. Move left, move right, do nothing, or shoot. To get better, we use a tactic called experience replay, which is basically like how a human learns from different experiences. If we play a video game once, then we'll likely be better at the video game the next time around. Except the deep Q network uses a lot more math than us humans do. For us, it comes intuitively. For deep Q networks, however, we store the current state, the current action, the current reward, and the future state that we transition to after completing that cycle. Then we store those 4 pieces of information in a database. And then when we're training in the future, that database gets randomly sampled from. So we can pick a past experience and see what we did there and iterate on. Say we're always given a scenario where the Space Invaders are always on one certain side. The network wouldn't know what to do when those same Space Invaders appeared on the other side. To avoid this, that's why we use experience replay. We sample from random experiences where the Space Invaders are on both this side and the other side. So it never has to be confused as to what to do when a new scenario emerges. We also need less data because we can train the agent on the same experiences multiple times. Now that's cool and all, but can DQNs really do anything other than play video games? It can actually do stuff that's way cooler than that. DQNs can be used in self-driving cars, robotic applications, and basically do anything that humans can that requires intuition. This means we can have AI-assisted helper robots that can help us with our everyday tasks. They can do anything that humans can do that requires general intuition. Traditional robots can only be programmed for a certain task. They can move this object to this location and back and forth. But with reinforcement learning, we can go here, 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 and everywhere that humans can normally go to. This may seem like a trivial task for humans, but for robots, we've struggled with this for centuries. This is insane for industries like manufacturing and service. DQNs can learn how to do all of those actions just by interacting with their environment, all on their own. Some people even think that reinforcement learning tactics are going to get us to artificial general intelligence. That's robots that think and feel just like humans. Now that's really scary, But for the time being, I'm super excited to see where I can take reinforcement learning in the future. Be sure to follow me on my reinforcement learning and artificial intelligence journey in the links below. For now, I'm gonna go work on a bot that trades cryptocurrency and can make me $1 million. See ya!